Okay, so the last part of our exponential equations part of this unit, because next we're going to be getting into functions, is compound interest. And I do have some good news. For compound interest, there is only growth. There is never a decay with compound interest. It just doesn't work that way. So the actual formula, and you'll see some variables that we've already worked with before. That is a 1, by the way. Okay, so there are some variables in there that we've already worked with. We already worked for A with A, so we know what A is, we know what R is, and we should know what T is by now. So the one thing that we are adding to this is N, and that's what tells us that it is compound. Okay, so that is the formula. So same thing that we dealt with before. We know R is rate, and we know all our little special pieces for rate. Okay, N is the number of times compounded. Okay, and it's the number of times it's being compounded in a set time period. Okay, usually that time period is a year, right? So if you're compounding something monthly, then you're doing it 12 times in a year. But when you're talking about things like in science, like lab work, and you're trying to grow things in a petri dish, maybe, then it might be that it's compounding every 2 hours. So you got to make sure we're reading what it says in the problems. Okay, and T is time, and we already talked about that one as far as the different times that we can put in there and the special rates that we can do. Okay, and A is, of course, our initial amount. Okay, so again, we don't have to decide whether or not it's going to be growth or decay. It is always going to be growth. We just have to substitute our pieces into our formulas this way. All right, so there are some special ones for compounding that we need to know. Okay, and again, I said this one already. If you are compounding monthly, then your N is going to be 12 because there are 12 months in a year. Daily, we actually use 365. I know there's 366 in a leap year, but we always just use the standard 365. Weekly is 52. Annually is 1. Okay, now there are some debates on semi-annually. Some people would say that semi-annually means every other year. In most cases for us, though, semi-annually means twice a year. And biannually means usually the same thing. So you could see biannually or semi-annually, and it normally means 2 times a year. Okay, so some very special ones. Make sure you've got these written down because these are the ones you're going to see the most. All right, so let's go ahead and jump in and get some practice done. Okay, and it's a lot like growth and decay. You're going to substitute in the pieces that you know. Okay, so how much will you have? All right, so that is our outcome. That's what we're looking for. Okay, starting amount of 200. Compounded monthly, that means N is 12 for 3 years. So T is 3, there's your time, at 5%. Okay, so we're going to plug it in exactly the way the formula shows. All right, initial amount. And this is going to be a fraction, and you do still need to make your percents into decimals. So it's going to be 1 plus 0.05 divided by 12, because you're compounding monthly, raised to the compounding times. This is 12 times 3 for your exponent. Okay, now you're probably going to want to do that part ahead of time, because putting in a multiplication as an exponent gets a little bit weird in your calculator. It doesn't like to do that. So you're going to want to simplify that first. The rest of it can just go straight into your calculator. So 201 plus 0.05 divided by 12 raised to the 36th power. And again, you are going to want to put that in 0.05 divided by 12. Hit your fraction button for that. Okay, and I am getting $232.29 because we're going to round to our nearest penny. Okay, make sure you're checking your calculator again. 1 plus, hit the fraction button so that you can put in the 0.05 over 12. And make sure you're, again, simplifying your exponent first, raised to the 36th power. Okay, let's try another one. Okay, now, just because this is how much you owe, again, does not mean it is a decay rate. When you're talking about a credit card, that is how it's going to state, is that's money that you will owe. So if you put $300 on a credit card, you will owe a certain amount. Okay, so 1 year. Okay, that's your time. How much will you owe is your outcome. That is what I'm looking for. 19% interest, there's your rate. Okay, compounded monthly, that means N is 12. And this is your initial amount. So you're putting $300 on your credit card and you're not paying on it. You're just letting it sit there, trying to figure out how much you are going to owe at the end of a year. All right, so let's set it up. So y equals our initial amount, 1 plus our rate as a decimal, 0.19 divided by 12. Okay, and then this is going to be 12 times 1, right? Because it's 1 year. I'm going to simplify my exponent. And again, you're going to put the whole thing in the calculator, making sure you hit your fraction button. And I am getting $362.24. Hopefully that's right. Yep, $362.24 rounded to the nearest penny. So yeah, if you don't do anything, if you don't pay anything on it, at the end of the year, you're going to owe $62 more than what you originally put on the credit card. So that's how that's going to work. All right, one more and then we'll be good to go. And we did this on a growth amount. As far as solving for a initial amount, it's not hard. You just have to simplify everything from the other side first. So let's take a look. So what does your initial amount need to be? So that's A. That's what I'm solving for. I want to have, there's my outcome, right? Because that's that future value, $1 million. Okay, I have my time, 20 years. I have my rate, 0.02. And I have my compounded monthly. All right, so we're going to plug all this in, or we're going to write it all out rather, and you're going to see how you are actually going to solve this. It's very, very similar to the exponential growth that we did before. So I want $1 million. Who doesn't, right? Okay, I want to have it in 20 years. So 1 plus compounded monthly with my rate of 2%. Okay. And then remember that this is n times t. So this is 12 times 20. And we're going to simplify that, right, before we put it in the calculator. So 1 million, 6 zeros, 1 plus 0.02 over 12. And 12 times 20 should be 240. Okay. So you're going to put this whole thing in the calculator, right? Because we're going to divide both sides by that. So in your calculator, you actually should be able to put 1 million divided by with the fraction button. And yes, you can put a fraction inside of a fraction. It is possible. And you're going to put it in just like that, since that's what you're dividing by on both sides. All right, let's see what we got. Okay, and I am getting $670,543.28 rounded to the nearest penny. Okay, and if you're not getting that, we need to figure out why. So if you're having issues getting these answers in your calculator, make sure you show me how you're putting it in the calculator tomorrow in class, and we'll go over and figure out what's going on. All right, that is it. I will see you next time.